Lesson: AI-driven risk mitigation strategies. AI-driven risk mitigation strategies are transforming the landscape of risk management by providing advanced tools for predicting, identifying, and mitigating potential threats. By leveraging the power of artificial intelligence, organizations can enhance their ability to manage risks more effectively, particularly in complex domains such as blockchain technology. This lesson delves into the actionable insights, practical tools, and frameworks necessary for professionals to implement AI-driven risk mitigation strategies effectively, providing a comprehensive understanding of their application in real-world scenarios. AI technologies, such as machine learning and natural language processing, have revolutionized the way risks are managed in industries where data is abundant. Machine learning models, for example, can analyze vast amounts of data to identify patterns and predict potential risks before they materialize. For instance, in the financial sector, AI algorithms can detect fraudulent transactions by analyzing transaction patterns and flagging anomalies that may indicate fraudulent behavior. Such predictive capabilities allow organizations to take proactive measures, thereby reducing the potential impact of risks. One practical framework for implementing AI-driven risk mitigation is the CRISP-DM model. This framework provides a structured approach to data mining projects, which is crucial when developing AI models for risk management. The CRISP-DM model is divided into 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. By following these phases, organizations can ensure that the AI models they develop are aligned with their risk management objectives and are based on high-quality data. For instance, in the context of blockchain technology, AI can be used to enhance security measures by predicting and preventing cyber attacks. Blockchain networks, while inherently secure, are not immune to attacks, such as the 51% attack, where a single entity gains control over the majority of the network's mining power. AI models can be trained to monitor network activity and detect signs of such attacks in real time, allowing for immediate countermeasures to be implemented. Another key aspect of AI-driven risk mitigation is the use of natural language processing to analyze unstructured data, such as social media posts, news articles, and regulatory documents. NLP can be used to monitor sentiment and detect early warning signals of potential risks. For example, by analyzing social media data, AI can identify negative sentiment towards a company or product, which may indicate emerging reputational risks. This allows organizations to address these issues proactively, thereby protecting their brand and market position. In terms of practical tools, AI platforms like TensorFlow and PyTorch provide the necessary infrastructure for developing machine learning models tailored to risk management. These platforms offer pre-built algorithms and libraries that simplify the process of model development and deployment. For instance, TensorFlow's TensorBoard can be used to visualize the model training process, helping data scientists to fine-tune their models for better accuracy in risk prediction. Additionally, AI-driven risk mitigation strategies can be enhanced by integrating them with other technologies, such as the Internet of Things and big data analytics. IoT devices can provide real-time data that feeds into AI models, improving their predictive capabilities. For example, in supply chain management, IoT sensors can monitor environmental conditions and provide data that AI models use to predict potential disruptions, such as delays caused by adverse weather conditions. Furthermore, AI-driven risk management can benefit from the use of hybrid models that combine different AI techniques. For instance, combining machine learning with expert systems can provide more robust risk assessments by integrating human expertise with data-driven insights. This hybrid approach is particularly effective in complex domains where human judgment is essential, such as regulatory compliance and legal risk management. Case studies further illuminate the effectiveness of AI-driven risk mitigation strategies. A noteworthy example is the use of AI by JPMorgan Chase to optimize its financial risk management. The bank has implemented AI algorithms to analyze market data and assess credit risk more accurately, reducing its exposure to potential defaults. This approach has not only enhanced the bank's risk management capabilities, but also improved its operational efficiency by automating routine tasks. Moreover, AI-driven risk mitigation is not limited to large corporations. Small and medium-sized enterprises can also leverage AI to manage risks more effectively. For instance, AI-powered chatbots can help SMEs monitor customer feedback and detect potential reputational risks early on. By automating this process, SMEs can allocate their resources more efficiently and focus on strategic initiatives that drive growth. However, implementing AI-driven risk mitigation strategies also presents challenges. One major concern is the ethical implications of using AI in risk management. Issues such as data privacy, bias in AI algorithms, and the transparency of AI decision-making processes must be addressed to ensure that AI-driven strategies are both effective and ethical. Organizations must establish clear guidelines and ethical standards for the use of AI in risk management to mitigate these concerns. In conclusion, AI-driven risk mitigation strategies offer significant potential for enhancing risk management practices across various industries. By leveraging machine learning, natural language processing, and other AI technologies, organizations can predict and mitigate risks more effectively. Practical frameworks like CRISP-DM provide a structured approach to developing AI models, while tools like TensorFlow and PyTorch facilitate their implementation. Real-world examples and case studies demonstrate the effectiveness of these strategies, highlighting their applicability to both large corporations and SMEs. However, ethical considerations must be addressed to ensure the responsible use of AI in risk management. By understanding and implementing these strategies, professionals can enhance their proficiency in managing risks in an increasingly complex and data-driven world.